Ever found yourself working with Ruby code and thinking, man, I wish I could just tweak how strings work a tiny bit? Or maybe add a helpful method to integers.
Yeah, that feeling's pretty common.
You might have even done what's called monkey patching. It feels like a quick fix, maybe even a bit magical sometimes.
But it often comes with strings attached, doesn't it?
Exactly. What if there's a better way, a more, controlled way to make those changes?
That's what we're diving into today, Ruby refinements.
Right. So if you've ever needed to adapt existing Ruby code, maybe your own stuff, or even code from a gem, this is going to be super relevant.
Definitely. Understanding refinements gives you a much more solid and, frankly, safer way to operate compared to, well, the Wild West of monkey patching.
We're looking at an article that really breaks down how refinements came about in Ruby and why they're generally seen as a better alternative.
Our mission really is to get clear on why they're better and how you can actually use them effectively in your projects.
Okay, let's get down to brass tacks then. This monkey patching thing, what is it exactly?
Well, the article explains it pretty simply. You're essentially just reopening a core class, thing, string, integer, those fundamental types,
Uh-huh.
and you just add new methods or maybe even change how existing ones work globally.
The article gives that to bool example, right? Like wanting yes or one to act like true.
Exactly. With monkey patching, you literally just open string and stick a to bool method in there.
Like this piece of code they show.
Ruby.class string.def to bool, case down case, 1% true, yes, 1 then true, 1% false, no, 0 then false, else raise argument error, invalid boolean string, hashtag rather, else raise argument error, invalid boolean string dot end, else raise argument error, invalid boolean string, end.
So then, bam, any string anywhere in your app can suddenly call .to bool. True.
Yeah.
To bool gives you true.
Seems super convenient at first glance.
It does. But, and this is the big but, the article points out some pretty major downsides.
Yeah, the first huge one is the scope. It's global, meaning you've just changed how every single string object behaves everywhere in your entire application, whether you intended to or not in that specific spot.
Ah, okay. So it's not just where you use to bool, it's like a fundamental change to the building block itself.
Precisely. And that leads to, well, subtle bugs, things breaking in weird places, and it's really hard to track down why, because the change is invisible, it's global.
It's like, changing a rule for everyone without telling them.
Sort of, yeah. And then there's library conflicts. The article mentions active support, which is a big one in the Rails world.
Oh yeah, active support famously adds loads of methods to core classes.
Exactly.
Right.
So if your monkey patch happens to define a method with the same name as one active support adds, or maybe changes behavior active support relies on,
Things can go boom,
uh,
unexpectedly.
right, you pull in a new gem, suddenly your app acts weird, and you spend hours trying to figure out if it's your patch or their code. It's a real-time sync.
And just managing it all, especially on bigger teams.
Nightmare. Who added this global patch? Why? Is it still needed? It just becomes spaghetti over time. Really hard to maintain.
Okay, so monkey patching. Convenient maybe, but definitely risky. Seems like a recipe for headaches down the line.
Pretty much sums it up.
So this is where refinements come in as the hero.
That's the idea. The article positions them as the solution. They came in experimentally in Ruby 2.0, then got fully baked in 2.1.
And the key difference is,
Scope. That's the magic word. Refinements let you make these same kinds of changes, like adding to bool to string, but the changes are scoped. They only apply within specific modules or classes where you explicitly activate them.
activate them. How?
With the using keyword, you define your change inside a module, say Boolean string.
Right, like the example.
Yeah. And then in the file or module where you actually want strings to have that to bool method, you write using Boolean string at the top.
So it's opt-in locally.
Exactly. Outside of where you put using, the string class is completely normal, untouched. Like putting on special glasses. The article sort of implies the view only changes while you wear them.
Okay, I can immediately see how that tackles the problems. Scoped changes mean to bool only exists where I said it should,
Correct. No more accidental global side effects.
which directly prevents those library conflicts we talked about. Your to bool won't clash with active support stuff unless you're specifically using your refinement in the same place.
Exactly. The isolation is key. And it makes debugging way easier too, doesn't it?
How so?
Well, if something weird is happening with a string, and you know you're in a block that's using a refinement, that's your first place to look.
Right, you don't have to guess if some global patch somewhere else is the cause. The change is localized.
Makes life much simpler. And for maintenance, it's cleaner. You can see exactly where these enhanced behaviors are being applied. Much more transparent.
The article also mentions something about Ruby 2.4, making things even better. Import methods.
Ah, yes. Import methods. That's basically about code reuse.
Okay.
So imagine you have the logic for Taboola already defined nicely in a regular module, maybe for other purposes.
Right.
Instead of copying and pasting that code into your refinement module, import methods lets you just pull that method from the regular module into the refinement.
Oh, neat. So you define the logic once and then just reference it within the refinement.
Exactly. Keeps things DRY. Don't repeat yourself. It avoids duplication, which is always good for maintenance, like grabbing a specific tool from your main toolbox to use in a temporary workspace.
Okay, that makes sense. So we've seen the dark side of monkey patching and the refined light of refinements. Why should someone really make the switch? What's the big sell?
Well, think about bigger projects. Multiple developers, different teams, maybe.
Yeah.
Using global monkey patches there is just asking for trouble.
Yeah.
Someone changes a core class, breaks someone else's feature. It causes friction.
Right. Refinements avoid that by keeping changes contained, less stepping on toes.
Precisely. It smooths out collaboration. And if you're writing gems, libraries that other people will use.
Oh, yeah. Definitely don't want to break their code with your global changes.
Absolutely not. Using refinements means your gem behaves predictably and doesn't randomly alter core Ruby behavior for your users. It's just safer, more responsible library development.
Makes sense. What about just, like, trying stuff out, prototyping?
Also a great use case. Refinements give you a safe sandbox. You can experiment with adding methods to classes in a limited scope. Try it out. See if you like it.
Without committing to a global change that might bite you later.
Exactly. And one more thing, the article highlights performance. There used to be maybe a slight overhead with refinements, but apparently since Ruby 3.4, that overhead is significantly reduced. So even that argument for monkey patching's simplicity is weaker now. Refinements are practical performance-wise too.
Okay, so lots of good reasons.
Yeah.
Are there any, like, best practices, tips for using them well? The article had some advice, right?
Yeah, definitely some good pointers. First, keep the scope tight.
Meaning?
Don't just refine string or object broadly if you can avoid it. Try to apply the refinement only to the specific classes or even methods where it's truly needed. The more targeted, the better.
Okay, minimum necessary scope. Makes sense. What else?
Naming. Choose really clear names for your refinement modules.
Boolean string was pretty clear.
Exactly. Make it obvious what the refinement does. It really helps readability down the road. Avoids that, what does this magic do, feeling you sometimes get with patches.
Good point. Anything about debugging?
Yeah, the article mentioned Ruby 3.4 actually gives better error messages now with refinements. If a refine method isn't active when you expect it, the error should be clear about what's going on.
That's helpful. Beats cryptic errors any day.
For sure. And finally, just reinforcing that import methods point.
Right.
Reuse code where you can. Don't copy-paste logic into refinements if it exists elsewhere. Keep it clean.
Okay, great tips. So just to wrap our heads around this, we started with monkey patching. Quick and dirty way to change classes globally, like adding Taboola everywhere.
Right, but with big risks. Global scope messes, weird bugs, library fights, and just general maintenance pain, especially on teams.
Then refinements came along as the more disciplined approach. Define changes in a module,
Activate them only where needed using keyword.
which solves the big problems. Changes are scoped, no surprise conflicts, easier to debug, much cleaner to maintain.
Exactly. Especially valuable for bigger projects, essential for writing safe libraries.
Right. So the big takeaway for you listening, next time you feel that urge to just reopen a core Ruby class, pause.
Take a breath.
Yeah, think about refinements. It might feel like one extra step, defining the module and adding using.
But the long-term benefits for code clarity, for stability, for just plain sanity, they're almost always worth it.
It really promotes a more robust way of coding in Ruby.
It does, which leads to maybe a final thought for you to chew on.
Go on.
Have you personally felt that pain? Spent hours debugging something that turned out to be a sneaky monkey patch interaction somewhere unexpected? Or, looking at your current projects now, can you maybe spot places where using refinements instead of a global patch might make things clearer, safer, just better managed?
It's worth thinking about, right? How could this more disciplined approach actually improve the code you work on day to day? Something to consider.